morning. Today, we will see how to test a resistor, capacitor, diode, and inductor. This test will show if the components are in working order or already broken. So, let's go! But before testing any components with a multi-tester, we need to first follow these steps. Number 1. Test if your multi-tester works properly and is accurate. Second, turn off the power if the equipment is attached to a circuit. And third, wear protective equipment like shock-resistant gloves. Now, let's test a resistor. First, find the resistance rating of the resistor. You can find the resistance rating of the resistor by decoding the colors on the side of the resistor. Second, set the multi-tester into the ohms that is in the range with the resistance rating of the resistor. So, example, if the resistance rating of the resistor is 10.10, then put the dial to the times 10. Third, place the test probes on the leads of the resistor. And fourth, read the scale reading and see if the resistance rating matches the scale reading. If the scale reading matches the resistance rating of the resistor, then the resistor is still good. Now, let's watch a demonstration.
In order to test a resistor, you should first disconnect one lead from the circuit. It doesn't matter which one. Next, you will want to obtain an electrical meter capable of measuring resistance. This is usually called an ohm meter and is often a function of a standard multimeter. Before proceeding, you will want to determine the rated value of the resistor that you would like to test. If your resistor is of the colored band variety, you will need to look up each colored band to determine its meaning. Typically, the first two bands will represent single-digit numbers. The third band represents a multiplier, and the fourth band will be an accuracy rating for the device. The ceramic and wire varieties of resistors will often be labeled in ink with a value. Carbon and metal variable resistors will usually have a stated value labeled, but you can also look for a smooth transition as adjustment is made to the wiper position. After determining the rated value of your resistor, set your meter to an appropriate range and connect the leads. Polarity does not matter. Compare your reading with the value determined above. It should be near the given value and within the tolerance range. If not, the resistor has most likely gone bad.
Let's test a capacitor. First, discharge a capacitor. You can discharge it by using a screwdriver. Second, turn the dial to the high range of ohms. Third, connect the leads of the capacitor to the test probes. And fourth, read the scale reading. A capacitor can react in three ways. A short capacitor will show extremely less resistance. A open capacitor will not demonstrate any deflection over the ohm meter display. And a good capacitor will illustrate a low resistance after that slowly increases in the direction of infinite. So the capacitor is in an excellent state. Now, let's watch a real-life demonstration.
Capacitor. These are the probes. Take the capacitor and first discharge the capacitor with the help of any screwdriver. This capacitor is 47 MFD and 160 volt. Touch the both probes on the capacitor terminals. As you can see, the multimeter needle is showing very little deflection because of the capacitor value is 47 MFT. Let's check once again. Discharge the capacitor once again and touch the both probes to the capacitor terminals. Let's see what will happen. Just see the display of the analog multimeter. The needle is showing very little deflection. This capacitor is working good.
Next, let's test a diode. First, turn the multimeter selector switch to low ohms. Second, connect the red probe of the multitester to the anode and black probe to the cathode. This means the diode is forward biased. Third, read the scale reading. If the displayed value is in between 0.6 to 0.7 for a silicon diode, then the diode is healthy and perfect. For germanium diodes, this value is between 0.25 to 0.3. Now, reverse the terminals of the meter. In other words, connect the red probe to the cathode and the black probe to the anode. This is the reverse bias condition of the diode, where no current flows through it. Hence, the meter should read OL or 1, which is equivalent to an open circuit. If the meter shows irrelevant values to the above two conditions, then the diode is defective. The defect in the diode can be either open or short. Now, let's watch a demonstration.
Sa 1K times 1K. So ito yung probe ng tester natin. So ito yung positive, ito yung negative. Ang pag-check nito guys ay positive to negative, negative to positive. Ganun guys. And then kung i-check mo naman yung leak niya guys, ay positive to positive, negative to negative. So start natin. So yung itong may guhit guys, ito yung negative side niya. And then yung walang guhit, yun yung positive side. So sabi ko nga kanina guys, ay negative to positive, positive to negative. Ayan, tignan natin. Okay. So ibig sabihin ng ganyan guys, nag-steady siya. Ibig sabihin good. Now, baliktarin naman natin para makita natin kung leaky ito. Yan. So meron siyang konting leak guys, gumagala yung yung pointer. Tasan pa natin. Yan guys, kita nyo. So yan guys, ito ay leaky. So hindi na to good, sira na to kasi dapat one way lang. Kasi nga pagka ibig sabihin ng leaky guys, imbes na diretso yung flow ng current, merong bumabalik. So hindi na to okay. Next guys.
And last but not the least, let's test a inductor. First, turn the dial into the ohms. Second, connect the multitester probes on any two terminals of the inductor. And third, read the scale reading. If the measured value is in few ohms, then the conductor is working properly, because functional inductors normally show the resistance of few ohms. Usually, it should be greater than 1 ohm and less than 11 ohms. If you find the values near to these values, then it's perfect. If you measured inductor's resistance is high, then the inductor is defective and you must replace it. If the measured inductor resistance is very, very low, this indicates that the inductor is internally shorted and you need to replace it. Now, let's watch a demonstration.
If I check at ohm, it will give me 0.4 ohm. And here, while testing, never touch your fingers to the multimeter. If we see, if I will touch, it will take internal resistance from my body. Never touch multimeter while testing. Test probes. it's giving 0.4 ohm.